Hi, welcome to our introductory video for SESResultsViewer, which is used to process and display the plots and reports of all SES computation modules. In this video, you will learn how to open SESResultsViewer, how to plot a system's configuration data, and how to process and plot a system's computation data and produce reports. You can open SESResultsViewer directly from the SES software folder. You would open the Tools subfolder and then click on the SESResultsViewer icon to launch the application. SESResultsViewer will then open on this Backstage view. SESResultsViewer can also be launched from the CDEG startup screen from the buttons corresponding to the computation modules. The MALS module was used for the example in this video. The project has already been specified and the computations have already been run. So at this point, we could open SESResultsViewer via the MALS button by selecting Examine. But first, we'll take a quick look at our project in SESCAD, which we can launch after selecting the Specify option, also via the MALS button. As mentioned earlier, we'll be using a previously defined project for the purposes of this video tutorial. If you choose to run the project directly from SESCAD, then you could also open SESResultsViewer directly from here. We'll start with an overview of the different areas of the SESResultsViewer main screen. The top ribbon includes important buttons and an advanced plot section on the right. The data selection panel on the left side of the screen contains plotting buttons and options for configuring your plots. All of your plots and reports will be displayed in the Results Display panel, located on the right side of the screen. At the bottom right of the screen is a section where you'll find the thumbnails of all plots and reports produced in the present session. In the next section of the video, we will plot some configuration data from the MALS computation run of the system that we just saw in SESCAD. We begin by selecting the Configuration Radio button in the Data Selection panel. The Category Selector combo box defines the nature of the results to display: conductors and profiles, or the default value of currents and GPRs, which we will use. In the Results Selection combo box, you'll specify the type of results to display. The options available here depend on what was selected in the Category combo box above. For the example in this video tutorial, we'll choose leakage currents of conductor segments. For the labeling style, we can choose an option for labeling the conductors with text, which is the default option, color, or with both text and color. Labeling conductors with color can help you to more clearly visualize the distribution of currents or potentials in a system. Here we have selected the both option. In the lower portion of the data selection panel, we'll select the top view option from the plot view drop-down menu, and then we'll click the plot button to generate our plot. It is showing that the leakage currents are more intense near the grid periphery, as expected. You can customize the appearance of your plot via the Rendering button. Within the Configuration Display option screen, there is a General tab, which you can use to specify a title for your plot. In the Plot View tab, you can check an option to show the axes. And you can also expand one or more of your axes here. You can improve the readability of the data appearing on the plot by entering an appropriate value in this Height of Character field. Sometimes it takes a little trial and error to arrive at the optimal character height. So we'll go ahead and apply our changes. From the Color Levels tab, you can customize the color levels of your plots. And in the Font and Line Properties tab, you can customize the font and pen attributes for different elements, such as the axes, the titles, and the legends of the plots produced by the program. If you wish, you can also filter conductors that are displayed in your plot via the Conductor Filters search area window, which will appear on the screen when we click the Conductor Filters button. You can filter by multiple criteria, including conductor depth, radius, coding type, conductor type, length, segment number, or conductor number. Here, for example, we'll choose to plot data for conductor numbers 1 through 10. We click the Apply Changes and Plot button to generate our new plot, which will appear in the Results Display panel showing our filtered data. To take a closer look at the plot, we can zoom into the Results Display panel using our mouse wheel. Also in the Results Display area, a report with information about our system can be viewed when we click on the Report button, either in the Data Selection panel or on the Home tab ribbon. This data can be exported in a CVS file format by completing a short sequence of steps. We won't show each step here, but we'll note that the process begins by clicking on one of the Export Data buttons, either the one in the Data Selection panel or the one in the Home ribbon. You also have the option to simply save the plot and the report to your computer. Now we'll do some plotting of the system's computation data, which takes into account the observation profile that was defined in the project. We begin by selecting the Computations radio button from the Data Selection panel. As with the configuration section that we saw earlier, this computation section also includes a category drop-down menu with two options. For this particular project, you can choose between scalar potentials, which is the default selection, and conductor data. The scalar potentials option is selected when you're looking to plot touch, reach, and step voltages. With the conductor data option, you can plot quantities related to conductor data, such as currents and GPRs, and display them using the specified observation points. We'll keep the default setting of scalar potentials for the category field. For our first plot, we will plot scalar potentials, so we'll make the appropriate selection in the Result Selection drop-down menu. So here, scalar potentials represents the distribution of soil potentials over the grounding system, which we'll be seeing in a 3D perspective. With a Spot 2D plot, the computed scalar potentials will be represented as color variations in a two-dimensional display. You can customize the appearance of the plot via the Rendering button. You can enter a title for your plot. You can modify the colors that are displayed in your plot, and multiple settings are available for customizing the font and labels for the plot axes. The Observation Points and Profiles Filters button allows you to zoom into an area of specific interest of your system. To use the geometric search area, click the Use Search Area box in the Search Area tab, and then click the Zoom button. Then select an area of interest, and next click on this button called Zoom In and Send Points. Now, when we close the zoom window, we'll see the coordinates of the nodes of our selected area here in the Search Area tab. We click on Apply Changes and Plot. And we'll see that the plotted area is now restricted to the region that we had zoomed into. If you want to zoom back out to the original plot that included the whole system, simply return to the Observation Points and Profile Filter screen and uncheck this Use Search Area button, and then again, Apply Changes and Plot. Now we'll plot touch voltages and learn how to specify the safety threshold. So we select touch voltages in the Result Selection drop-down menu. Then, in the Define Safety Threshold panel, we select Specify a Threshold module. Then we click the small button next to this field. This will bring up the Threshold Editor window, where you can specify settings appropriate for your project to compute the safety thresholds for touch and step voltages. For simplicity, in our example, we will use the default settings. Additional information about how to use the features in this window is available in a separate video tutorial for SES Threshold. To compute the safety thresholds in the Threshold window, click the Compute Only button located in the Home ribbon. The computed safety thresholds will appear in the Results panel. Then click OK to return to the SES Results Viewer main screen. You will see that the computed threshold for touch voltages appears in the threshold value field. Now click the Plot button. When the threshold is applied, safe areas of the grounding grid will not be colored in the plot. The absence of colored areas here indicates that the threshold is not exceeded anywhere in the plotted area. Had there been unsafe areas, these would have been indicated as a colored region in the plot. Note that the same approach would be used to plot step voltages. Some advanced plotting features are available in SES Results Viewer, accessible via the Advanced Plot section of the Home ribbon. Here we'll take a look at a plot generated by SES System Viewer. Another type of advanced plot can be created in GR Server. Computation's results for horizontal profile surfaces can be exported to Google Earth. Note that for this demonstration, we will switch to another project prepared in advance for this purpose. Clicking on the Google Earth button brings up the Plot to Google Earth window, and here you simply identify a reference coordinate in the model for which the latitude and longitude in decimal degrees are known. And in the last field, angle, you specify the counterclockwise angle between north and the positive y-axis of your model. When we click on the Plot button, the program will convert the flat 2D coordinates to latitude and longitude in the resulting Google Earth plot. As we can see here, structures such as buildings will be shown in 3D. This concludes our video tutorial for SES Results Viewer. Thank you for watching.